Hi guys, this is Miss Nolte here. I am here to help you with your worksheet today. So Miss Sutton should have handed this worksheet out to you. So what we're going to do is we are going to go through this together, and hopefully that will help kind of clarify some of the questions or things that aren't quite making sense to you with all of this. So the very first thing that we're going to do is identify each of the pieces, okay? So this needs to be always your first step. Okay, so for number 1, your amplitude is 3. Your period, which is 2 pi divided by the b value, is, which in this case is 6. So you got 2 6, which reduces to 1/3, so that's 1 pi over 3 or pi over 3. The phase shift is the c divided by the b, so that's going to be the pi over 4 divided by 6. So when dividing a fraction by a number, you multiply those two denominator values. So we got pi over 24, and this, since a minus is up there, inside the parentheses is going to go to the right. Okay, we also want to identify if there's a vertical shift, and in this particular case, there is no plus d, so we have no vertical shift. So that is our step 1, is identifying those 4 pieces. Step 2 is going to be labeling the x-axis. So we got 4 increments here. The 4th increment is always whatever the power or the period value is. So that increment is pi over 3. So half of pi over 3 is pi over 6. And then half of pi over 6 is pi over 12. And I'm going to do that in the negative direction as well. Just kind of flip that. Okay, so then I'm going to label my y-axis. My y-axis is going to come obviously from the amplitude, and since I'm drawing a cosecant function, I need to be able to see the parabola. So I'm going to start with going by 3. So I'm going to go 3, 6, and then -3, -6. All right, so when it comes to labeling the vertical, or the vertical asymptotes, the way I always remember this is any function that starts with a c, so we're talking about cosecant and cotangent. Those first vertical asymptotes always usually start right on the y-axis. Okay, but since we have a phase shift to the right, pi over 24, I need to move that asymptote to the right, pi over 24. So since my first increment is pi over 12, pi over 24 would be exactly half of that. So my first vertical asymptote is going to be right in the middle of that first increment. Now I always like to highlight or put a little star next to that first vertical asymptote because that helps us to tell us where that first parabola goes. So now I'm going to draw a vertical asymptote every 2 increments. Okay, and that works because of the way we cut our graph. Remember, the 4th increment on the graph was whatever the period is. So we're kind of taking our function, our unit circle, and cutting it into 4s. And that's why we can always say the vertical asymptotes will always be every 2 increments, no matter what function you're drawing. All right, so now I'm going to draw my cosecant function. Okay, so it starts with a parabola, and it's going to start just to the right of that. First, the vertical asymptote. Remember that it's going to minimize at 3 and maximize at -3 on those upside down ones. Okay, and we need to be drawing 4 parabolas total. So I don't really care how you get 4 parabolas, but as long as I can see 4 of them, that's going to be 2 periods or 2 full revolutions around the unit circle. Okay, so I also want to show you guys how to make sure that you've done this correctly. Okay, this is not a tool to use all the time, but if you're stuck or just want to make sure that you've done it correctly, then you may use the calculator in order to verify what you've done. Okay, so I'm going to show you how to do it on the calculator. So the first thing you have to do is you have to, well, type this function in. So we've got 3 cosecants. Now, since there is no cosecant button on the calculator, I have to do its reciprocal. And so the reciprocal of cosecant is sine. So I'm going to go divided by the sine. And then after that, it's just exactly what I see on my equation. So 6x minus pi divided by 4. Okay, the next thing I want to just double check before I hit graph is I want to check my mode. It's important that your mode is in radians, otherwise you will not see what we see. We are graphing in radians. Okay, so now what I'm going to do is I'm going to adjust my window. Okay, and what we're going to do is basically copy the window that we are zoomed into here on the graph by the axes that we've already created. Okay, so the x is going to be between negative pi over 3 and positive pi over 3. So that's what I'm going to type into the calculator. So my minimum is negative pi over 3. Max is pi over 3. My x scale is what my scale is going by, what increment. Okay, so my first increment is pi over 12, and that is what my scale is going by. So pi over 12 for the x's. So now for the y, I go up to positive 6 and down to negative 6. So I'm going to go to negative 6, up to positive 6, and we're going by increments of 3. All right, so now I'm going to hit graph, and this is my moment of truth. Let's see if I did do this correctly. You should see 4 increments. And I'm not sure why it's not showing my x increments there. That's strange. Well, there should be 4 increments there. Oh, I see. I must have typed that increment scale wrong. Make sure that I wrote 12. Let's try one more time just to make sure I didn't accidentally type 2. There we go. There we go. That's better. There, now we can see those 4 increments. And now it looks exactly like the drawing that I just drew. Okay, so there's my verification to make sure I did that correctly. All right, so there's question number 1 done. Let's go ahead and do question number 2. So I think I'll do maybe the first 4 of these with you. I might move a little quickly because I am here at 7:30 tonight creating these notes, and you have a pause button, so here we go. Amplitude for this one is negative 7. Well, you can have a negative amplitude, so I'm going to call it positive 7. The period 2 pi divided by the b, which is 4, is going to make pi over 2. The phase shift is c divided by the b. In our particular case, there is no c, no adding or subtracting inside the parentheses, so I'm going to say none there. But we do have a vertical shift, and it is down 10. All right, so there's my step 1. Step 2 is labeling my axes. So my 4th increment is pi over 2. Half of that would be pi over 4. And half of that would be pi over 8. And going in the negative direction. Okay, so now the tricky part on this particular one is going to be my vertical shift and labeling my y-axis. So you can see that the amplitude is 7, so that would go up 7 and down 7, but I need to take those and move all that down 10 because I have a vertical shift of 10. So I think it might be easiest to say, okay, well, if I have an amplitude of 7 and I take that down 10, that would take me to negative 3. And so what I'm going to do is just draw a little dotted line, which is kind of like an asymptote, although not technically one, just to help me draw one, because the graph will actually touch that when it minimizes at the bottom of the parabola. But I'm just using that as a reference. Okay, and then for my bottom one, remember that it was originally negative 7 from the amplitude, and if I take negative 7 down 10, that's going to take me to negative 17. And I'm going to draw a little dotted line there. Okay. All right, so now I'm going to draw my vertical asymptote. This one is a secant function. So secants are the same as secant and tangent. So those both start on the first increment. So my first increment is pi over 8. So that will be where my first one lies. So I'm going to put a little star so I remember that's where it goes. Okay. And I'm going to draw 4 asymptotes every 2 increments away. Alright, so now when I draw this, there's one thing that I have not talked about. Hopefully you did notice. There is a negative in front of this function. Okay, so what I'm thinking about is this function that normally has a first parabola going right through the y-axis there, like that, is being flipped upside down. Okay, so instead of it being a u parabola, it's going to be an upside down parabola first. So my first one is going to be down here. Okay, and then I'm going to alternate. And again, I must draw 4 parabolas to have 2 full revolutions, and it's up to you where you want to draw your 4th one. I'm going to draw mine to the right. So that looks good. I'm going to go ahead and verify and just double check to make sure I did graph this right, because that negative is tricky. So I'm going to clear that out. So -7 divided by, let's see, we got secant. So the reciprocal of secant is cosine. So I'm going to do cosine of 4x minus 10. Okay, so then I'm going to go to my window, and I'm going to set my window to what I've got on my grid. So I go from negative pi over 2 to positive pi over 2. Negative pi over 2 to positive pi, over 2, and we're going by increments of pi over 8. That's that first increment there. Okay, now on my y, I've kind of adjusted this a bit. So that lowest one I've got labeled there is 17. So I want to be able to see the bottom of my parabola. So I'm going to go lower than 17. I'm going to go, let's just go -25. That should be good enough. On my grid, I go up to 14. Oops, 14. And I'm going by increments of 7 on my grid. Alright, here comes the moment of truth.